Good afternoon, everyone. Okay, microphone is on. So, good afternoon, everyone, and this is my personal revision series. So, if you like the subject and if you want to follow it along, please subscribe to my channel. Okay, I'm not forcing to subscribe if you want knowledge, and I do want to improve at speaking and writing, making notes. So, I am making this video. Okay, now this particular subject is discrete mathematics, and its weightage is about 7 to 9 marks in the GATE examination. So these are the topics listed. That is, first is set theory, relation, functions, graph theory, proposition and first order logic, and graph theory. Group theory and graph theory. Okay, it was my mistake. I said graph before. Now, so in it, the relation is very important, and this graph theory is very important. But it is not a fixed pattern of IITs to ask from the very important topics, as we seen this year that the IIT KGP has asked from wide variety of topics, and MSQ were more, NAT were more, and yes, that some things were particularly asked much time than expected. Okay, like the questions on the graph were there. So I didn't was I was not very sure about the answers, and my exam was not very good. So I have taken this initiative to make this video. Okay, let's follow back to the chapter. So I will start it up. So discrete mathematics. Now, what is set? An unordered, well-defined collection of distinct objects called elements or members of a set of same type. Here, the type is defined by one who is defining the set. So, I am making a set. So, the type of the set is defined by me, like collection of pencils, collection of number. So, these are the type I am defining. So, the system and the surrounding concept is used. Like I am defining the system and the rest out of it is surrounding. System જેને study કરીએ means what we study, and surrounding system ની બહારની વસ્તુ means the surrounding is the environment outside the system. Okay, so for example, A set A is 1 2 3 4, and set 2 set B is 2 1 4 3. So A equals to B, and this proves the point of unorderedness. Set is unordered. In standard set theory, duplication is not possible. Not possible. All elements will be distinct itself, and array and the set A is 1 A and no in Hindi. Is it a valid set? So I don't know the definition. How was this set defined? Maybe it would be have been the set such that x such that x belongs to first the first uh, symbol of number alphabet or and Hindi alphabet. Hindi. Okay, no is not the first number. So I will just particularly say no in Hindi, right? So if this was the way the set was defined, then it is correct set. But to so it was asked that whether this set is valid or not. So depends on how the set was defined, right? As I said, so the set was defined in this way, then it is correct. And but by seeing the set itself, we can't say what type it belongs to or whether it is well defined or not. Set are very flexible, and set denoted by the capital letter. So as we have previously seen that this set is said by capital letter, and the objects of set are called the elements of a member of the set. Elements are usually represented by small letter, and X belongs to A means X is a member of A. Remember this, IMP. This is the definition of belongs to. Means X belongs to A means X element X is a member of A. X does not belongs to A means X is not a member of A. But in this real life, there could be fuzzy set. Means that X belongs to A also and X belongs to B also. It does not belongs to A also. So like this can happen in only real life. Like example like I belongs to college, and now due to corona I don't belong to college. Like I am in the college but I don't go to college. So this would be a fuzzy set in itself. Now, but this type of fuzzy sets are not possible in discrete mathematics. It is only two cases that are possible. Either X belongs to A or does not belongs to A. Next, cardinality. It is the number of elements present in a set. It is denoted by mod A. Mod A. For example, A is 0, 2, 4, 6, and mod A equals to 4. Correct? Because there are 1, 2, 3, 4. It, there, okay, let me ask a question that if there can be, whether there can be a set which is defined like this. So answer is, please take a time to make sure that your answer is correct or not. But the answer is no, because there is repetition or duplication in here, and the set, according to the definition of the set theory, there could no duplication, like distinct, see, distinct objects, so there could be no duplication in the set. So this is an invalid set. Now representation of a set. Tabular roster representation of a set. Tabular or roster representation. So here a set is defined by actually listing its member. For example, see, A is a set A, E, I, O, U. B is a set 1, 2, 3, 4. C is a set like even integers. Okay, we'll see this afterwards. Set builder form, set builder representation of a set. Here we specify the property which the element of a set must satisfy. So X such that criteria. This is the property which X must satisfy. S is the name of a set. Element in a set. X is the element in set. This line is called such that, and the criteria for X to be in S. So here is are some example of set builder form, like X such that X is an odd positive number less than 10. Odd positive number less than 10. X such that X belongs to English alphabet and X is a vowel. A, E, I, O, U, right? English alphabet and vowel. X such that X belongs to N and X is less than 5. 1, 2, 3, 4. X such that X belongs to Z and X modulo X remainder, when X is divided by 2, its remainder is 0. In short, mod 0 mod 2. So finite set. If there is exactly an element in a set where n is non-negative integer, we say that S is finite set. Okay, we can define the cardinality. So this is very important definition. Like it says that when we can define the cardinality, which I said as like this, mod A, then we can say that set is finite. Infinite set. Set of star is infinite. Set of water molecules, H2O molecules on the earth. Whether this is finite or infinite, answer it. I have written the answer alongside only. It is finite. See, this is the reason why I was saying, like, we'll see this afterwards. So earth mass is finite, right? Earth's mass is finite, water on the Earth. So if Earth is itself finite, like whole set is finite, Earth itself a set, then water is just the subset of the finite set of Earth. So itself, so the water itself is finite, right? So therefore, water molecules, so water is finite. So we can also find the water molecules by dividing the total weight of the water by mass of one molecule of water. Countability. Here is one concept of countability. So natural number has a simple infinity. So 1 to infinity are simple infinity, and integers are from negative infinity to positive infinity. But we can map each element of integer to each element of a number without any. Hmm. So we can map it, like you can say that we can map element of any set with a natural number because they both are infinite. So therefore, this statements of one-to-one mapping holds true, and they are called countable infinites. So here one question was asked: will modulo of n less than modulo of z, cardinality of z? So the answer is false. It is not right. We cannot define the cardinality of the infinite set. So the finite set ની definition શું હતી કે જે કાર્ડિનલિટી ડિફાઇન થઈ શકે ને તો એને ફાઇનાઇટ સેટ કહેવાય. But for infinite set we cannot define the cardinality, so therefore it is called infinite set. Natural number and integer, who is more powerful? Okay, natural number and integer, who is more powerful? So if we are given 8 bits each, okay, so integer will natural number will give us unsigned value, unsigned range of 2 raised to 8, 0 to 2 raised to 8 minus 1. Okay, so here it will be this. So 0 to 255, 8 bits in integer will give us minus signed bits like minus 128 to 127, but the total of both will be 256. So they both have same power. Natural number are the simplest infinity possible. Now we have mapped before the integer and natural number, but can we do the mapping of natural number with the real number? So the answer is no, because the real number is infinity inside infinity, like it is infinite itself, but between the two number also there is an infinity, so they are uncountable. So is natural number and real number are same level of infinity? No, because as we seen before, because we cannot do one-to-one mapping, we have two classes of infinity, one with natural number and real number infinity. So natural number infinity is countable infinity, real numbers infinity is uncountable infinity. So now set of stars, are they finite or infinite? See the answer, it is written infinite. But this infinity is countable because we can map this set of stars with natural number. But can I, that is integer, but okay, this is for me itself, it is pronoun. But can I number them? Yes. So now we can do one to one mapping with natural number with every star in the set. So this is a function from n to s, that is s is star here. So we can say that the stars are countable infinite. So sets are of two type: empty set, non-empty set. Finite, countable, So finite will always be countable, there is no doubt in it. But non-finite, non-empty set can be both finite and infinite. Finite are always countable, infinite can be countable as well as uncountable. So countable infinites example has been given before, that is integer and natural number. Uncountable example is real number. Which of the following is are not true? So there are a couple of statements and we are asked to find not true statement. So the set of negative integer is countable. Yes, because negative integer can be mapped with natural number, can be mapped by natural number. So they are countable infinite. And the set of integer that are multiple of 7 are countable. Correctly. So 7 countable will be plus 7 minus 7 plus 14 minus 14 plus 21 plus minus 21 and so on till infinity plus minus infinity. So this two can be mapped by natural number. So it is countable as well. Now the set of even integer number is countable. Correct? Even integer can also be mapped with natural number. Therefore it is also countable. And the set of real number between 0, here see real number is present. So real number between 0 and 1 by 2 itself is infinite. Is it countable? Can we say that real number is countable? No, uncountable. So therefore this statement is false. Natural numbers cardinality equal to this integer's cardinality. As we have seen before in this above example, see, it was comparison between two infinite sets whose cardinality itself is not defined. So there is no point of comparing them, can't be compared. See, null set and empty set. These are two new sets introduced. Like null set, it is a unique set with no element in it. Its size or cardinality is 0, that is, this is 0. Mod of phi is 0. It is denoted by symbol phi or brackets, empty brackets. A set with one element is called singleton set. Here also singleton, I have not written. And this A is denoted by empty braces, so it is empty set, or A is equals to phi. This symbol over here, like this symbol is wrong. The null set or empty set cannot be represented by braces and phi set inside the braces. Like this is set itself, valid set, but not an empty set. Not valid representation of empty set. It means set is having phi as empty set. This too as well is not a valid representation. Only this and this are only valid representation of empty set. Universal set. So if all the set under investigation are subset of a fixed set, like we've seen before, that system system is our universal set, like what we take into observation. Okay, when I'm taking number as 1 2 3 4 5 like this, so this much is my system, like universal set. So therefore if all the set under investigation are subset of a fixed set, so if I take 1 2 3 4 5, so this A and B are subset of this union set, universal set. So that is the set containing all objects under investigation in a Venn diagram. It is represented by a rectangle. Venn diagram we'll talk later, which is a diagram to represent a set, and it is denoted by universal set U. So universal's complement is phi. Subset of a set. Every set, every element, if every element of a set A is also an element of set B, that is, for all x belongs to A, X also belongs to B, then it is called A is called subset of A, and it is written as A subset B. Whereas B in here is a superset of A. Superset here subset. So A is 1, 2, 3, 4, 1, 2, 3. B is 1, 2, 3, 4, 5. Therefore, we can say that A is subset of B and B is superset of A. Don't mind my spellings. Okay, I'm writing very roughly right now. Now these are some important points. Phi is subset of any set. Empty element is subset of every set. A is subset of universal set. Every set is a subset of universal set. A subset of itself, like every set is subset of itself. A not subset. So here we see the another observation, like so A not subset to B when every element of A, with some element, some, this is what we can say quantifier. We will see this topic in preposition, like we can read it as for some A not belongs to B, but A belongs to A. So here was the definition of not subset of A, not subset of B. सो ए में कुछ ऐसा एलिमेंट होना चाहिए जो बी में ना हो, तभी वो कह पाएगा कि ए इज नॉट सबसेट ऑफ बी. ए इफ ए इज सबसेट ऑफ बी, of subset of equal to b, so is there any possibility that a equals to b? So we can say that it may be equal to b, which would be true, but here it is directly said that a equals to b if a subset of b, which is absolutely wrong. We'll see this later. Proper set. So A is subset of B. A is subset of B as it is written here. A is not equal to B. B has at least one element which is not in A. Let us make an example. So here it is given A 1, 2, 3, B 1, 2, 3, 4, 5. So here we have represented by like what we can say that representation. Okay, A is 1, 2, 3. Over here A is 1, 2, 3. This set is B. So B has 1, 2, 3, 4, 5, and A is whole completely inside the B. So therefore A is proper subset of B. 4 and 5 are explicitly with B, hence A is proper subset of B. Equality of a set. So if two sets A and B have the same element, and therefore every element of A also belong to B and every element of B also belong to A, then set A and B are said to be equal set and written as A equal to B. So here is the smaller definition. ये तो मुझे भी पढ़ते पढ़ते नींद आ गई. A is subset of B, B is subset of A, then we can say that A equals to B. Power set. So power set क्या चीज़ है कि अगर कोई सेट है हमारे पास तो उसके सारे पॉसिबल सबसेट का जो सेट बनता है उसे पावर सेट बोलते हैं. So let A be any set, then the set of all subset of A is called power set of A, and it is denoted by P of A or 2 raised to A. If A is 1, 2, 3, then power set of A, I'll write here again, is 5, 1, 2, 3, 1, 2, 2, 3, 1, 3, 1, 2, 3. Okay, the total elements will be in it is 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. We'll see this uh, number of element thing later. Like right now, you just see how it is represented. Power set is represented. So power set is denoted by P of A or 2 raised to A or power set. Cardinality of a power set. So see here in above case that 1, 2 and 3 was a set A. So its cardinality was 3. Power set was made from it which was having cardinality of 8. As we counted here 1, 2, 3, 4, 5, 6, 7, 8. 8. So we derived a formula for it like power set's cardinality is 2 raised to n, where n is the number of elements in a set whose power set is made. Okay, this is one different logic of how we came on to this like equation. So there were three elements in A, right? 1, 2, and 3. We tried and we uh, written down all the cases of 3, like they can be present in a set subset or cannot be present in a subset. So they have two cases, 0 or 1. Okay, so 0, 0, 0, 0, 0, 1, 0, 1, 0, like this we have written 8 combination. So therefore there is 2 raised to n. So there are some true or false example. So phi belongs to A. Phi belongs to A. Is it true? See, I have written something. You must be thinking this is true, right? But this is false. It is very important thing. Phi belongs to A. So A was 1, 2, 3. Does you do you see phi in it? Huh? See, I have written something like member होता है तो दिखता है. So if A is 1, 2, then phi does not belong to A. Member होता है तो दिखता है. Phi दिख रहा है हमें? नहीं दिख रहा है. So मतलब वो member नहीं है. It does not belong to A. Phi is subset of A. वो बोल सकते हैं क्योंकि phi सबसेट है. कोई भी सेट का सबसेट है. वैसे हमने पहले ही लिखा था. ये रहा. Phi is subset of every set. That is true. Phi belongs to 2A. 2 raised to A, that is power set. So power set में तो ये शानदार तरीके से दिखता है. Phi. Phi belongs to power set, true. Phi belongs to, and this is subset, right? Both are true. Power set में phi देखा है. मीन्स पावर सेट में phi दिख रहा है, तभी हम उसे मेंबर बोल पा रहे हैं क्योंकि वो दिख रहा है पावर सेट में. और सबसेट तो होता ही है किसी भी सेट का. तो यहाँ पे भी ये ट्रू हो गया. A belongs to 2 raised to A, which is true because see, A was 1, 2, 3. A itself can be seen in here. So therefore A is member of power set, which is true. And A is subset of 2 raised to A, which is false. Like A has 1, 2, 3. So can you see 1 as an element in power set? No. We can see like this A, 2, 3. But we didn't see A as in this form without curly braces. So therefore it is not subset. A is not subset of 2 raised to A, but A belongs to 2 raised to A. If every member of A are in power set of A, then only it would be 2 raised to A. Means then only it would be A subset of power set of A. Like here I have written the same thing which I have explained here. Things required in life is patience. Okay, this is very true for GATE examination. I have did some mistakes like I have not revised properly and frequently. I have not attended lectures properly, and I haven't made notes properly. This was the first time I'm making notes after taking after considering my mistakes in past examination of GATE, like 2022. Okay, so I prefer you make notes. I will also share these notes in YouTube description. You can avail it from there also. And it won't be just marked what I'm writing on it. It won't be like that. Okay, it will be in a simple form. You can just annotate whatever you want, or also I'll provide both the notes. Let it be. So this is very important. Fill in the blanks. I guess it was asked in GATE as well. I don't remember it because I haven't written it. Like for every questions I have written GATE, but this did belong to GATE. So power set of 5. Wow. Suppose A is 5. So cardinality of A is here, and we are asked the cardinality, right? I haven't seen that. So power set of A would be like this only, and power sets uh, cardinality will be 2 raised to 0 is 1. B equals to power set of A. So it was this. So power set is 5 and bracketed 5. Its cardinality is 2, as it can be seen 1 and 2. Power set of A. So 5 bracketed 5 double bracketed 5, and this B था जो वो पूरा यहाँ पे. So it is equals to power set of B, as I have written. Its cardinality is 4. 1, 2, 3, 4. Cardinality of a power set of 0 to 10 element. So their total element is 11, because 0 to 10 and 2 raised to 11. That is 2 raised to 10 is 1024 into 2 plus 1 is equals to 2048. So for a set A, the power set of A is denoted by 2 raised to A. If A is equals to 5 bracketed 6 set 7, bracketed 6 की जगह पे set 6 set 7 भी लिख सकते हैं. Which of the following options are true? Like 5 belongs to 2 raised to A. Number होता है तो दिखता है. 5 belongs to 2 raised to A. Yes, true, because in power set we can see 5 by the open eyes. By दिखता है मतलब समझ लो तुम. And 5 subset of 2 raised to A. 5 subset of any and every set. So then this statement is also true. This statement is also true. And 5 and this set 6 belongs to 2 raised to A. इसका पावर सेट बनाना पड़ेगा. See, power set this A has 5, 6, 7. Hey, wait. Why am I doing this stuff? I got it. Here it is. 5, and this is the power set 5 and 7. Just see this here. I won't be able to speak out. This is the power set. This element belongs to it. Where is it? Here. But can you see this element? Is it a subset? False. When we say like this, 5, 6, subset of 2 raised to A. So we are not considering this whole set. We are considering its element. Like element of 5 and 6 should be in like 2 raised to A. So 5 and 6 should be present inside 2 raised to A. So 5, I can't see it anywhere. And bracket 6 is also not visible. Only double bracket 6 is visible, which is over here. So this statement is therefore false. So we were asked to find truth statements 1, 2 and 3. See, देखाय છે means दिखता है when it is belongs to 2 raised to a, not subset, belongs. Important point is 5 and 6 subset of 2 raised to a, which is false. मैंने यही पूछा है जो आपको अभी बताया कि 5 और 6 ऐसे दिख रहे हैं हमें. So 5 and 6 are not present in 2 raised to a. Power set of 5, this set is 5, 5. Ta-da! Whenever we want to find the power set, so by default 5 appears and the set itself, like whole set, this is itself a power set. The number of elements in a power set P of S, power set of the set S is this. It has 3 elements 1, 2, 3, therefore 8. 2 raised to 3 is 8. Power set denotes the power set, like P of S denotes the power set of a set S. Which of the following is always true? So power set intersection power set of power set is equals to 5. घोर अपराध. Like consider S equals to 1, 2. Power set of S 5, 1, 2, 1, 2. Power set of power set, this will have 16 elements. But तुम समझो यार, पावर सेट ऑफ पावर्स. अरे यार मैं इतना बह क्यों जाता हूँ भावनाओं में, लिखने लगता हूँ जो भी चीज़. यहाँ पे लिखा है मैंने s इक्वल्स टू 1, तो उसका पावर सेट में होगा 5 और 1 s सेट. एंड पावर सेट ऑफ पावर सेट, इसमें 2 एलिमेंट है, इसमें 4 एलिमेंट होंगे. 5, दिस सेट 5 डबल ब्रैकेटेड 1 एंड द सेट इटसेल्फ, ये जो सेट था पावर सेट था वो. इंटरसेक्शन 5 कभी नहीं हो सकता. ये गलत लिखा है मैंने यहाँ पर. अच्छा, ये एक्चुअली सही है. My mistake. I should like take a rest for you guys because we have discussed much in this lecture. We have discussed 2 lectures in this particular session. So we'll just conclude by by मतलब increase by uh, deceiving my mistake. Deceiving is hiding, right? Hiding my mistake. Okay. So in this 2 sets we can see 5 element. So अगर A के पास 1 2 एलिमेंट है, B के पास 2 3 एलिमेंट है, तो उसका A इंटरसेक्शन B कैसे बताएंगे हम? It will be like this only, right? So तभी मैं कंफ्यूज हो गया क्योंकि मैं सोच रहा था कि ऐसे मिलेगा हमें, बट मिलना चाहिए था ऐसे. So therefore it is true, absolutely true. Okay, goodbye. We'll see you in the next video of revision series. Bye bye.